well, thanks for coming this afternoon. We're emulating a board meeting here at the for the Computer Information Systems Department. It's likely that somebody could want to join us a little late. We don't lock the door, so to our guest speaker, if people come in, just continue. But this is a simulation of what project that he's been assigned. We're going to let him introduce himself. Should be approximately 15 minutes of presentation, and so then we want to encourage you to ask questions of him at the end as well. And so, all right, our speaker today, I'll let you introduce yourself and we'll begin.
Hello, my name is Joel McCaughey, and I'm part of the CIS department, and I'm going to be presenting my senior project today. So my original proposal was that I was going to make a cluster of machines that would be able to run an application known as Acumos, which then I would use to create an artificially intelligent application. So to get started on this, I took a bunch of machines just from the closet in the CIS department, and so then I constructed my own simple network of just all 8 of them together, and then I connected them to a switch and then to a router so that they could all each be internet accessible. And so then I had to establish my cluster, and the two that I used during this process was Proxmox, which is a virtual machine management system where you're able to deploy virtual machines or containers. And then I also used Kubernates, which is also a container deployment system, but it's designed for more scalability, and it's meant to be more malleable in terms of infrastructure. However, that didn't quite go as I had initially thought with Proxmox, because it wasn't exactly what I had initially thought it was. And so then I did a little more research, and then I stumbled upon a Kubernetes installation wiki. And so to do that, I used an operating system called CentOS. I could have used Ubuntu, but I have plenty of experience with Ubuntu, and so I decided to go with something new. And so with Kubernetes, after I had installed CentOS on all the machines, I had to install Kubernetes on each individual machine and then have it clustered together. And before this, I had absolutely no experience with Kubernetes, and so this is all very new to me, and so I had to do very extensive hours of research. And so I had to get familiar with these 3 commands or applications. And a cluster is made up of what are called nodes, and there's a disparity between a master and a worker node. And a master node is what gives all the worker nodes their processes, which is what they're meant to do. And a pod is a collection of multiple containers, which are just miniature virtual machines, which can run very simple applications, like for example, a web server. And for Kubernetes, I just call them kubectl, kubelet, and kubectl. And kubectl is the main thing that you use when you're interacting with your cluster in total. And kubelet is what runs on each individual node as a service, which constantly sends packets and relays it to and from the worker node. And then Kubernates is the CLI application that you use to install and run a cluster. And CLI is also an abbreviation of command line interface, which is where you just type in all the commands as seen by those two windows. And this right here is, you can't really see it very well, but it's the command that I issued on all of the machines that were meant to be worker nodes, and it's basically is telling it to look for the master node, and then use an API key to connect to it, so that all of its services can go back and forth from the master node. And this right here, that right here is just a window that's supposed to be showing that all the nodes are online and that they're ready. And this was just a text file that I made to better manage my IP addresses. So because after it was all established, I just pretty much just used Secure Shell to remote in and make any changes from my lab machine. And then Docker. Docker is the main application that Kubernetes uses for containerization and deployment of all of its applications. And then the next phase was that that's when I installed Acumos. This is when I was was meant to install Acumos. And so initially I had gotten the installation scripts from the suggested source from their wiki, but then as I tried to run them, I ran into a couple of, I became hindered while trying to run it, because and this was a kind of a tougher process because of the fact that they're custom scripts. I'm not just able to look it up online if there's an error. But one thing I did eventually find out is that after I went through and started analyzing the code, I figured out that the scripts that I was using actually performs a benchmark. And what that is it basically evaluates my systems to see if it can actually run the application, and that's why I went with the approach with trying to cluster multiple machines to kind of get over that. However, you'll soon see in a later slide, which you'll see why that wasn't quite the case in this scenario. Distributed operating. This is what I was looking for. This is what I had in mind. And these are called distributed operating systems. And there was a concept that was that they had tried to use in the late 1990s, but with how fast technology was progressing, they eventually just decided that it was an obsolete concept, and so they pretty much stopped. And how it works is that every single machine has its own kernel, but then the overlying layer of the distributed operating system is supposed to take every machine's resources and kind of pool them together as a singular machine, which you could then use to run any application, which not just applications, but any services that you might want to use on it as well. So with that, there was one solution that I actually did find that was still being developed. It was called Popcorn Linux. However, I eventually, Popcorn Linux, Popcorn kernel. Yeah.
It works.
But I found out that it's aimed at running in a virtual environment, because how virtual machines work is that they're virtual machines on an actual piece of physical hardware, and so it's already using all those resources already. And so it works as by distributing itself amongst all your systems or virtual machines or virtual nodes that you might have to act as a distributed operating system, because it already has all the resources collected as one, because it already is one machine. And so after like 2 weeks of not making really any progress whatsoever, I was suggested on looking at what is known as the ElkStack, and ElkStack is an abbreviation for Elasticsearch, Logstash, and Kibana. And what each of those do is Elasticsearch is supposed to go through and parse and find pretty much any data that it's assigned to find. And then Logstash is meant to take all that data and organize it in a way that's actually comprehensible. And then Kibana is meant to act as the visual. It's meant to organize it visually, and it does that through a web interface, which can be accessed just either typing either a host name or its IP address. But something new that was added with the ElkStack recently was something called SIEM, which is it's like a security module in the ElkStack, which is meant to be like the system security guard. However, for this case, ElkStack, or the SIEM, is a premium service for the ElkStack, which you have to pay for. And so I wasn't really able to interact with it myself, but it can use what is called anomaly detection, which it pretty much just monitors your entire network, and if something goes amiss or there's something that is completely out of the ordinary, it's supposed to send an alert to whoever is monitoring the network at the time. And so with that, they can also, with the three of those resources, they're able to easily see where and when this happened, and any and all other information that could be relevant to it. ElkStack has a bunch of modules that can be used and that can be enabled to better increase the functionality and versatility of the ElkStack. And even though my project didn't quite go as planned, I still learned plenty. I learned how to use Proxmox and how to deploy VMs on it. I learned how to use and set up a Kubernetes cluster and deploy like a test application. I learned how to use CentOS, which I've used quite a bit of Linux distributions before. So the main thing that was different about CentOS for me was I learned to use the Yum package manager, which is how Linux distributions manage it and install their applications and tools that you might want. And also I learned about distributed operating systems and how those work, and I was able to learn about the ElkStack as well. So.
It would be appropriate to ask if anyone has any questions.
Do any of you have any questions?
Yeah, how long did it take you to do this?
Like
the whole project?
The whole project?
Yeah.
I logged around like 97 hours, which was close to the goal that I was aiming for.
Along with that, what was your greatest challenge throughout this project? 'Cause I know you talked about a couple of hiccups you had along the way. What really stuck out and what was really challenging for you?
Definitely the part where I had the mishap of not really being able to continue with installing Acumos.
In your mind's eye, I need a better explanation of two pieces of software, but in your mind, what is Acumos? What would you have made with this Acumos that didn't work?
Acumos is supposed to be like a framework, it's supposed to make it easier to design your own artificially intelligent application. And I'm not quite certain what I would have made if when I got into that point. But the applications that we made can use machine learning, which can identify patterns, which can be used to draw conclusions based on their input.
And then what is ElkStack used for?
ElkStack is mainly used for, it can be used for network monitoring. It can also be used to monitor the overall functionality and of your network, and can be used for just as like a way to analyze your traffic data.
And did you happen to have any screenshots of being successful with ElkStack?
I
But
was
you
curious
said,
about that too. Because you couldn't, the piece that cost, and we didn't have resources or whatever to move beyond that, did that keep you from being able to use ElkStack with any sort of effectiveness, or it only kept you from using it the fullest way you intended? I mean, like, did that really kind of shut you down with ElkStack? Or were you still able to use ElkStack to some benefit, even though you couldn't do the?
No, I was able to run ElkStack on a virtual machine, but I couldn't get it here though because of where we are. It's in the party center,
Yeah.
and we're here in the library. But I was able to get it working.
and so what network are you monitoring?
The 8 machines on your cluster, is that right?
No, when I moved on to ElkStack, I kind of just completely moved on because I really wasn't really sure what else to do with that.
So you weren't using the 8 machine cluster anymore at that point?
No.
Okay. So did you get your 8 machine cluster to do anything together? I mean, other than be recognized? Like you got the master and the,
That was something that I also couldn't figure out quite, because when I was trying to deploy, it kept on just saying that the container was creating, and it just got stuck, and it just hung on that. And when I tried to look at it, it just kept on saying unknown error, which I eventually found out was because it was benchmarking it. And so it was saying that it couldn't do it because it didn't have the right network resource, or the needed hardware resources.
so if you had more RAM, et cetera, then it
Um,
likely would have
I
completed.
did try to also do this on a virtual machine in one of our servers, and it turns out that even logical, like it needs to be 16 physical cores, but
Right.
not logical. And it needs, the RAM we were fine on, because the servers have 44 gigs, but
But it needed 16 cores to process.
so then I moved on to the ElkStack.
I'm still
And the
unclear.
ElkStack,
Oh, go ahead.
as of right now, it's monitoring itself, but not our network, because it had me do a lot of changes that, like, if people want to come and see it, I'll show them, but I really didn't want to compromise its functionality until after this.
For, just on your little system, or you mean like the CIS department network?
It's just monitoring itself as just a
No,
virtual.
so if you, but like the functionality you wanted you to change, would that have changed the bigger network? Is it plugged into the departmental network, or when you talk about network, do you mean it's just your project's own little?
On our big network, the only thing I really would have had to do was just have it, because for pfSense, you can tell it to send the log files over to another server. The only thing that I would have to do that I didn't really want to do without compromising its functionality was make it have to parse those files and then organize them.
ElkStacks do that.
Will this have a place in the lab? Will it ever be effective for our lab? ElkStack?
It certainly could be.
I mean, you know our lab pretty well. Do you think it's a better tool than anything we have running currently? I mean, there are lots of options, right? Lots and lots of tools we could plug in and use, but is this something we want to make a change?
I mean, it does make it easier when it comes to looking at just network events, but you can also do the same thing with pfSense. So the only real change that we could have if we paid for it is just anomaly detection, just to see if there was like any security risk.
Which would certainly be interesting, but how much does that cost? Is it a monthly fee or annual fee or just a one-time software purchase or?
Can't quite remember, but I have looked at it. It's like the platinum package, and I think it's like around $60. I don't know if it's. I think that might be monthly.
We probably don't want to do $60 a month for anomaly.
Not for anomaly
detection.
checks, that we're already behind a firewall that's
Yeah.
pretty helpful.
Yeah.
No.
It would be interesting to see it run. But if we don't have any anomalies, so we wouldn't have any data really to mess with anyway, so,
That's Kerry's job,
yeah.
and we're behind him.
What about taking the whole idea, go back to the original plan to build a cluster so that you could do some sort of an AI project, right? That was the dream from the beginning. So what do you need? Either hardware, software, licenses, experience, or what would you need to go back and to build in our lab a multi-machine?
It doesn't need to be multi-machine. That's just kind of the approach that I went towards.
Well, I mean, that's, yeah, but I like that approach. I mean, it's one thing to have a bunch of virtual machines, but to see that you can make multiple machines work together on a single problem is pretty cool. We don't,
But that's really not much of a thing anymore because of how fast technology already was going along at that time. So distributed operating, like if you're talking about distributed operating systems, which is what I had it was the idea that I initially had my mind set on, but I didn't know that at the time, that wasn't already a really developed concept.
right, and there are other ways to do distributed computing besides using a distributed operating system across connected machines. Right, so you don't need multiple machines to handle some sort of distributed program. Still be interesting to see it.
But to answer what you had first, I would just need I pretty much just need just like a higher end server
With 16 cores.
and at least 32 gigs of RAM.
Based on the price we just paid for one with only about 4 core, I think we're not going to get one.
Yeah. But you said you had 8, right? 8 cores, you needed 16 cores.
When I tried it on the one in our lab, those ones only have 6.
Okay. So did you know in advance, I mean, was there any documentation that said like minimum 16 core, or that's just something you figured out?
There
or
was,
learned?
but that's why I went along with the cluster part of it, because I thought it could kind of get rid of that middleman.
But you have to have it all set up on the, like your master
But
has
the
to be the
benchmarking-
16.
The benchmarking prevented me from doing that.
Yeah, and then you can add others if you can finish that.
Well, you're also saying, well, was it a limitation if we just didn't have enough of the small machines? If you'd have stacked 16 small machines, would you have ever gotten there?
I don't think so.
Still wouldn't benchmark the first.
No, I don't think so.
You gotta make them work together before you can hook them up to work together. If you're gonna count on all of them providing your 16 cores. That doesn't work.
Do you think every CIS student should have to do a senior project?
I mean, yeah.
Now that you've done one, the rest of them should have to too, right?
Make it even worse on them next time.
Yeah, make it harder.
I have a basic question, not necessarily about this,
Mhm.
but which computer information system class do you feel has best prepared you to go out into the working field?
Definitely networking, advanced networking. I did really enjoy that class, but I really do want to go into security and pen testing, which is ethical hacking. And so understanding networking has definitely made me, like, it's really expanded my knowledge and know-how as to how to even pull those kinds of attacks off.
So how are you going to get to that? What kind of certifications are you going to get to add into that, the hacking and
I haven't really looked at any certifications. The only certification that I know of is from the AP something or other. It's been a long time since I've actually looked it up. But
Security Plus.
yeah, that's it. Yeah, that's the
The
security.
CompTIA?
Yeah, the
But-
CompTIA.
CompTIA, but they're connected with who now?
Yeah.
is that all
But-
part of that?
I never had actually.
Pardon?
ATIT?
Yes.
Yeah, that's it.
What about, and then, after 5 years, most people, if they really want to get into security and security hacking, is the CISSP. I mean, you might want to put that on your long-range goals.
I haven't really looked at any certifications. I mean, everything that I know has been self-taught, and I've been going at it and I've been teaching myself since high school.
Well,
So
and
I've become very proficient.
you
Definitely
know
not-
the acronym she just said, you may not be thinking about. CCSP is Cisco certifications, and you know about Cisco certifications, just not to that level at that point.
Yeah, you start.
And you do have something lined up for the summer, don't you?
As of right now, it's looking that I will get a summer internship at a place called Fiducial. It's where Craig Houchin works. And I don't know if I would be doing security there, but or if it would just be general IT. But over last summer, they did hire me to be like they did hire me to be a pen tester.
That's pretty fun.
And they paid you. That's exciting. And so now it would be appropriate to ask if there are any more questions, and then thank folks for coming if they do not have any more.
Any more questions?
It was a very aggressive project, because we don't have courses in AI or anything like that, to try the clustering and everything.
That was my biggest aim, was to just really challenge myself.
Yeah, okay. I mean, it's always a little bit sad when the project doesn't work out as anticipated, because you'd like to have the, here, yay, hurrah, look what I did, and it all works, and so you miss that bit of excitement of a completed project. But it was an aggressive project, but I'm glad that you challenged yourself.
So, thank you all for coming.
All right, and as you've been here before, and if this is your first time, we're looking for feedback. He's going to get to see that. On the back of the page, there's some check boxes. If you think you saw that he used any of those features, you just put a check there. Those are called our course objectives. You don't have to mark them all. We're just trying to get a feedback for if we cover different types of things and give some objective feedback. Thanks for coming. Once you've given us that, you're free to go, and we appreciate your support. Let's give Joel a big round of applause.